need. So you'll be asked to describe a data set, or describe a box plot, or describe a stem plot. Or, for example, if I said, describe to me what this looks like, the box plot on number 4. That's a valid AP question. If they ask you that, there's 4 things that you have to address. And they start with SOCS. That's just like my way to remember it. So the first S stands for shape. There's a bunch of different possible shapes. The most common one is probably approximately normal. And that's your bell curve. You know, this is like an SAT score. Most people get 1,000 is the average, so most people are pretty close to 1,000. As I get better and better, higher scores, there's fewer people that get those scores. As I get lower and lower, there's fewer people that get those scores. Most people are clustered in the middle, and then as you get further away from the middle, it gets a little more rare. So it's approximately normal. We haven't really spent time on normal distribution yet, so for now, you could say bell curve if you wanted to. But that only lasts for 2 weeks, because then you have to say approximately normal, because then we learn it. So. There is bimodal. What does mode mean? There's mean, median, and mode, right? What's mode? The most. It's the one that happens the most. So bimodal means there's 2 locations that it happens the most at. So you get a hill over here, and then not much data over there, and a hill over here. So this would be and this happens sometimes when I get tests. There'll be a chunk of people that get 90 to 100. And there'll be a chunk of people that get a D. And nobody gets in the middle. It's just kind of you either really understood this stuff, nobody really kind of understood it, or you didn't. So there's 2 separate chunks of data. That didn't happen on this test, but there's uniform. Uniform is everything's the exact same. I'm going to put the examples we talked about. So we talked about SAT scores for that one. This would be A's on the test and D's on the test. And nobody got a B or a C. Or very few people got a B or a C. Uniform would be if everybody's going to have the same answer. So if I went down to the senior wing and started graphing what grade everyone is in, it'd all be 12, right? So every answer is the same. Or everything equally likely is a good way to say that too. Those are probably the 3 easiest to understand. Let me make sure there's not another one. Okay. So then we get into skewed. So let's do skewed right first. So skewed right, there's a lot of different ways to think about this. The biggest, the most easiest way to prove it is to say the mean is greater than the median. In a box plot, it would look something like this. So you'd have your median here, but the data above the median is really spread out, and the data below the median is not very spread out. So when I start averaging, what's going to have a bigger impact on the average? The spread out huge numbers or the numbers that are like just a little bit below? There's going to be the spread out huge numbers, right? In like a bell curve type of thing, it would look like this, where most of your data's here, but then you got like this tail over here, and these extreme values over here will pull your mean. So these extreme values here, those pull your average up. If I have like 3, 4, 5, 6, 7, what's my mean? Or what's my median there? 5. What's my average? What's my mean? What's the average of those numbers? What's right in the middle of all those numbers? This is not supposed to be a trick question. It's 5. Yeah. That's just, you got 5, and then you got 6 and 4, and then you got 3 and 7. So if I average them all together, it's 5. That is not skewed right. But what did I just do to the median? No, I didn't. What did I do to the median? I didn't do anything. The median is still 5, isn't it? I can make that 7 million. What's the median? 5. But what did I do to the mean? I just increased it a ton, right? So that's what skewed right is. Where you got, so that would be something like this. Like this isn't, you know, a 3, 4, 5, 6, 7, that first box plot I made would look like this. But then when I put that 700 there, all of a sudden we're like, woo! And this is what pulls the mean up. So skewed right, another way to say that is the tail is on the right. Let's talk about a couple of real life examples of this. Anybody got one? I should probably do one first before I ask you first. So the most common, I think easiest to understand is like people's income in the United States. Because most people are, you know, you can't go lower than 0. So you can't be like really extreme in the negative direction. You know, you got poor people, you got people that are middle class, you got people that are upper class. But then you got like Bill Gates. Does Bill Gates affect the median? No. If you list them in order, he's just still at the end. But does Bill Gates affect the mean? Yes. So examples would be people's income in U.S. So Bill Gates skews mean up or to the right. So you get this kind of shape again where, you know, you got some poor people, you got some middle class, you got some upper class, and then you got a few just billionaires that just jack. The billionaires do not affect the median, but they jack the mean way up. And I'll see that sometimes. Like the average income in the U.S. is $200,000. Well, that doesn't tell me anything because you're including people that make like $600 trillion a year. That doesn't represent like a true what's really going on in the middle. So median is a much better thing. So median is more valuable than mean because median is not impacted by outliers. Where the mean is impacted by outliers, right? I want a couple more examples. I'm running out of room, but I want you to take a minute or two, write down a couple or work with someone next to you and give me a couple real life situations that would be skewed. If I graph them, they would be skewed to the right. So you have a couple outliers like on the high end. They're not super easy to think of. That's kind of why I'm having you do it instead of me. I'll give you an interesting example someone used last year. The number of fingers. No, what did they say? Because some people have 6 fingers. Have you guys ever seen that? So the number of fingers on someone's hand. Because like pretty much everyone has 5. And you might get some people that have a couple cut off, but I guess there's like a chunk of the population that has 6 fingers.
I feel like more people would have.
See, I thought that too, but I don't know. I was just throwing it out. I just thought it was funny. Think about the toes and the... Anybody got one?
Yeah, we got one.
What do you got?
Like Madden ratings.
Madden ratings?
Because like no one's like lower than like a 50 something.
Okay.
But like there's some people who are at like 99s.
So there's more like 99s than there are 50s?
Yeah.
And they're usually like 70 or 80?
Yeah.
Okay. Not sure everyone really understands that, but as long as you do, that's cool. If I went to run a mile with the cross-country team, that would be skewed up. Because the cross-country team, like how long would it take you guys to run a mile? 6, 7 minutes? So you'd get this chunk of people at 6 or 7, and then Mr. Davis at like 20. That would skew up the average. Any other ones? She said, like, if the baseball team, like, if everyone was hitting about the same average, like 300, 400, then you got one person hitting like 700, that would skew that up. That's not always the case, but that could be. Yeah, what do you got?
It's just said like with heights, like you have everyone that's like average, like if you everyone's around like 5'5", and then if you just have this like girl that's like 6'8".
So is this class, what do you think this class is? Skewed right, skewed left, or approximately normal? Think I skew it right?
Are you involved in it? Yeah.
Let's do it.
Are you involved?
Yes, I'm involved.
Okay, then it's skewed right.
Never mind. It doesn't. It's not going to work the way I want. Yeah. So let's. If I were involved, is it skewed right?
Yes.
If I'm not involved, it's probably less skewed, right?
Yeah.
I don't know if it's like perfectly normal, but do you get the idea what skewed right is? That's all we're going for here. Any other examples you want to share? All right. I want you to write the notes, your own notes, and I'll write them up in a second. But you write the notes for skewed left. Because it's just the opposite, right? So you think through it, you write the opposite of what I just wrote, and you make your own notes for skewed left. And I'll put mine up so you can check. But it's better if you come up with it on your own. The box plot on the board, is that skewed right or skewed left? That's skewed right. That 195 and that 160 are pulling the mean up. They don't affect the median, but they pull up the mean. If Mr. Packer were in here, the heights would be skewed left. Rather, are you taller than Mr. Packer? You're not taller than Mr. Packer. What are you, like 5? Like 5? 5 foot even? So here's what I put for the top of my notes. I didn't do any examples yet because we didn't talk about them. And I just made up this number list. You can make up whatever you want, but the median here would be 101, right? And the mean would be pulled way down because that number's way farther away on the downside than the numbers on the upside. Say it again.
The tail on the left, oh, the average down.
Pulls the mean down.
Okay.
Yes. So try to think of a couple or one or two of those examples where something will pull the mean down. Say test grades. A lot of tests I give end up looking like this, where this might be the A's, the B's, the C's, and then there's like someone that gets like a 12. That happens a lot in integrated math because there's people that just don't give a crap, So most people get A, B, or C and they're fine, and then I get a couple people that turn on tests and they get like a 0, which sucks. But it seems impossible. But that's gonna pull the mean down, right? In this, let me ask you this. This is a good question. It's a good AP question. I give a test that looks like this. This is the distribution. My principal comes to me and says, "Hey, how's your AP stats kids doing?" I want it to sound good. Do I give him the mean or the median? The median, right? If I wanted it to sound bad for whatever reason, I don't know why, but I'll give him the mean. So that's like, you can really twist data around by giving one or the other in a situation like this. You can really make things seem one way or the other. Any other examples? I'll give you a minute or two. Yeah.
Like usually basketball players are very tall, so like kind of like basketball players' heights, and you get the really short ones.
Yeah, so if you went to like an NBA team
Yeah.
and then threw Mr. Packard on the floor,
Yeah. That's what I'm talking about.
that would skew down. Yep.
Mr. Packard has some great basketball skills.
I'm a little worried about your obsession with Mr. Packard.
Was it Dino Boy? Yeah, what's his name? Mr. Packard.
He what?
Mr. Packard. He basketball coach for his son's basketball.
Oh, yeah.
And there was this kid that was like obsessed with dinosaurs, and he was like really bad at Mr. Packard always does. No, every time Mr. Packard would shoot like a paper one in the trash can, he'd make it. He's good.
Mhm. What else? Give me another one.
So like there's like the two players that are really good, and then the one player is just really struggling, and they bet high, and then they get the question wrong. It makes sense in my head.
So, like the result afterwards, you mean? Like they'd be way lower?
Yeah, because they bet more and got the answer wrong. So now they're at like 100 when everyone else is at like 30.
Okay. I mean, there's only 3 people, but I get what you're saying.
What about like the amount of AP classes students are in? Because like some people are in 0, so it brings the mean down, but a lot of people are in like multiple.
I would say that would be skewed up. Do you think more people are in AP classes or not in AP
No,
classes?
Because freshmen.
Yeah, so I think you would get like 0 would be like that many people, and then you might get like 1, 2, 3, 4.
Oh yeah.
So that would be actually skewed right. Does that make sense?
Yeah.
I think you understand the skew. That example just didn't work the way you hoped it would.
Yeah.
I go to like a baseball game and I watch all the pitchers throw their fastballs and I write down how fast they're throwing. It's like 95, 92, 98, 91. And then Riley goes out and throws. And it's like 12. And that'd be skewed left. If it was 200, it'd be skewed right. And you shouldn't be here. You should be pitching the plate, making millions of dollars. Alright. Does that help for skewed right and skewed left? Is that good? Alright. The O. And that's the hardest one. So we did shape. The O is for outliers. We've talked about that, right? So that's anything beyond 1.5 Q3 plus 1.5 times the IQR, or Q1 minus 1.5 times the IQR. On a graph where you don't have the data, it's just anything really far away. They'll make it very obvious if there's an outlier on a graph where you don't have the data. So for example, if I gave you a histogram like this, would you think there were outliers there? No. But then if I put one way over here, So C is for center. There's a flaw in my SOCS method here. People see the word center and they'll write the word center on their test sometimes. Center is a way to remember. You can use mean or median for center. But you cannot say the word center. So I almost want to do like SOMS, S-O-M-S, but that's not a word that you'll remember. I don't know. But you can't tell me the center is this. That doesn't mean anything. Center could be mean or median or mode, but I don't really think of a situation where we'd use mode. But just don't tell me the center is 12. I don't know what that means. Is that the mean or is that the median? So you're describing the center, but you're not saying the word center. And then the last one is spread. And you got options here also. So you could do the range. How do I find the range? Biggest minus smallest, or like max minus min, right? You could do IQR. How do I find IQR? Q3 minus Q1. Or, and you haven't learned this one yet, but this will be a big one as we get going, or you can use standard deviation. You won't use standard deviation like on this next test, because we haven't talked about it yet, but we eventually will. And then, as with everything we do in here, we try to put what in the description if we were doing one? Context. So let's say this was IQ scores of people in this room. I want you to describe that data. So just write out the shape. Are there any outliers? Tell me the center. Tell me the spread. Give me SOCS. Give me the socks for this one. The 195 is obviously me, in case you're wondering. Definitely right. Average IQ is 100. So this would be like a crazy smart room if that were actually the IQ scores. I don't even know how reliable those tests are. But yeah, totally. And they like, how do they measure? I don't understand how it can be possible. There's all different types of intelligence.
Right.
Like I might be really good at that test, but I might suck at putting, common sense or like building stuff or cooking or art or music.
Yeah.
Yeah. So if I were writing this out, I would say the data for IQ scores, so what did I just do? I gave a context, is skewed to the right. So where that bigger spread is, where that tail is, where that pull is, that's the direction of the skew. The skew to the right. There is one outlier at 195. Am I going to use mean or median? Median, because I don't know the mean. The median is 110. The IQR is, 40? I can't see my numbers. 40. Or you could say the range is 95. But that would get you the full credit there. So you used context, you told me the shape, the outliers, the center, and the spread. How many have something like that? Questions? Alright. I'll wrap it up. We'll work on some those Frappy Pack a little more tomorrow, doing stuff like this. But you guys are good for now.